on behalf of our Center Director, Pete Warden, his senior management team, the people in the SOFIA Project Office, and my colleagues in public affairs. It's my pleasure to welcome you here today. We're thrilled to have you, and we hope you have a wonderful day. As you probably guessed, despite the slide on the screen, I am not Dr. Pamela Markham. Although she does such exciting work, maybe sometimes I wish I were. But I'm David Morse. I'm what's called the Dean of Students here. You may not know we have 1,000 students here in the summer. Well, we say we're committed to STEM education, science, technology, education, and math, and encouraging people to enter those fields through the work we do and the products we create. We're serious about it, and we prove it with those 1,000 student interns on average every summer. We have about 200 during the year, when of course it's much more difficult for students to be here. We have a great day planned for you today. I have to consult my notes every now and again to make sure I don't forget anything. And we hope that you'll take the opportunity to share what you see and what you think through your tweets, your blogs, and any other communication devices you choose to use. We encourage that. That's a large part of the point of being here today. So please take every opportunity you can to do that. In a few minutes, we'll board a bus, and our first tour stop will be the NASA Advanced Supercomputing Facility. I stumble over the words because it's changed its name a few times. It used to be the Numerical Aerodynamics Simulation Facility, but they carefully kept the NAS acronym. So NASA Advanced Supercomputing Facility, and what you will see there is an amazing supercomputer called Pleiades. Pleiades was recently found to be the 7th fastest supercomputer in the world. For about 5 minutes it was once number 1, and then somebody came along with a bigger and quicker one, as happens all the time in that field. To put in perspective for you what Pleiades can do, it can do 1.3 quadrillion calculations per second. So for those of you not mathematically inclined, that's 10 to the 15th power. 1.3 times 10 to the 15th power. I am mathematically inclined, and that still doesn't mean much to me. So let me put it to you this way. If a human being could do 1 calculation per second, every second of every minute of every hour, 24 hours a day, 365 days a year, without taking a break to sleep, eat, use the bathroom, or anything else, it would take you a little over 40 million years to do what this computer can do in 1 second. We want to make you all feel real bad to start the day here. Of course, the calculations it does are very simple. It compares 2 data sets, it can add them together, things like that. But it can do it tremendously quickly, and so it gives us the capability to solve very large problems, to fly vehicles in a supercomputer and see how they will perform, to look at global climate modeling, things like that, things on a very vast scale that require huge compute capability, and then the visual display that goes with it so you can see what's going on. So Pleiades will be your first stop. Then we'll move on to the vertical motion simulator. It's a 6-degree of freedom simulator, by which we mean it can go up and down, right and left, forward and back, it can roll from side to side, it can pitch forward and back, and it has the motion we call yaw, like spinning on a turntable. It can do all 6 at the same time. It has a 60-foot vertical displacement, and we can swap the cabs out. There's something like 5 cabs. We can make it a rotorcraft, a helicopter to the rest of the world outside of NASA. We can make it the space shuttle. We can make it a variety of vehicles by swapping the cab. We build the data handling of that vehicle into the software, and then we can put people in it, and it's as if they're flying the real vehicle. And it indeed is where the shuttle astronauts learn how to fly the shuttle, including landing at all the abort sites, which is critical if there's a problem on liftoff. After that, then you will go across the street to actually board and see the SOFIA vehicle, the Stratospheric Observatory for Infrared Astronomy, the highlight and the main point of today's tour. And then Thomas Rolig, the Deputy Project Scientist, will take you on the aircraft and we'll talk about the vehicle. After the tour, we will pose in front of the SOFIA aircraft for a photograph, which will memorialize your visit, and then we'll head back to the bus to lunch here. Okay. So when you come back here, of course, you'll have a chance to mingle. We'll have it set up with tables so that there's some flat tops. You can tweet, you can engage, etc. And Roger Hunter, the Kepler mission manager. I'm sure many of you are familiar with Kepler. It is our spaceborne telescope that is looking for planets like or sized like our Earth, orbiting around stars like our Sun. And so far we've found on the order of 1,235. We'll probably update that number today. But Kepler's another exciting project we have here. So before we get going, let me ask you, how many of you have been to NASA Ames Research Center before? Oh, quite a few of you. That's good. That's exciting. I expected a much smaller number. Let me just give you a few quick facts. Ames was NASA's second center. Langley was the first. We weren't called NASA at the time. We were called NACA, the National Advisory Committee for Aeronautics. Originally, we were an aeronautics center, but like all the other centers, we have morphed into a variety of fields. At Ames now, a lot of our focus is on enabling NASA missions, not managing NASA missions per se. Now, SOFIA and Kepler are two examples where we are managing missions. But in most cases, we're developing technologies and doing the research that make NASA missions possible. And we do that research in the Earth, life, and space sciences. One of our primary interests at Ames is what we call astrobiology. We're interested in, does life exist only on Earth? Has it existed elsewhere? Could it exist elsewhere? Could we take another planet or an asteroid and terraform it and have life exist in those areas? Those are the kinds of subjects of astrobiology. In a simple phrase, it's the origin, the evolution, the distribution, and the destiny of life in the universe. And SOFIA and Kepler are two of the primary platforms or tools we use to conduct our astrobiology research. So that just gives you a little bit of a background and hopefully puts it into context and perspective for you. Probably it would be best, I don't know if we've got time to do this with everybody. Let me ask, who's traveled a great distance to be here? Okay, I know many of you are from the Bay Area. Yes, ma'am, where have you come from? Cambridge, Massachusetts, good. Anybody else that's traveled?
San Diego doesn't really count.
Oh, San Diego, nice. You've given up great weather, I assume, to come to our... It's not bad today. Yeah, 69 degrees, I think it was when I came in. All right, normally I'd go around and have you each introduce yourselves, but I don't think we have a lot of time to do that, and I'm not sure how useful that is. Let me tell you, you should share amongst yourselves your Twitter name. Mine is DRNNASA, my initials in NASA. I got there quickly and grabbed that one, just like I grabbed rocket scientist at eBay, and everybody's been asking me ever since to give it up, and I'm not going to. So I would share with one another, and share your thoughts on why space exploration is important to you and what it means to you. What it means to me, believe it or not, I'm not a space buff. I'm an economist by training. And what it means to me is not only that we do great space exploration, that we increase our national pride, that we discover new worlds, that we potentially colonize new places. What it really means to me is we develop fabulously important and valuable technologies that find their way back into our everyday life. Some economists, and you can't trust economists, they make assumptions, I'm the first to admit, but some economists have said we get 10 to 20 times what we invest in NASA back in the technologies we produce, regardless of the space exploration part. Now, I don't want you to discount that, but there are huge, valuable technologies developed, which NASA doesn't commercialize, but we work with companies to commercialize. And that, to me, is a key to the space exploration program. And everybody's going to have their own reasons. So I encourage you to talk to one another about that. Okay, so what I really want to do, and the time I want to save mostly, is for the aforementioned Dr. Pam Markham. Let me give you a one-sentence introduction, because I know Pam has a fabulous presentation she wants to share with you. So let me tell you, Pam Markham is the project scientist for SOFIA, and she's here to give you an overview of what SOFIA does and how it views the universe in the infrared region. So keeping it short to the point, not reflective of her stance, but to move things along, please give a warm welcome to Dr. Pam Markham.